What if a self-driving car could think in words? Not just ones and zeros, but actual language. We're going to take a look at a brand new kind of AI that's basically learning to drive by talking to itself. It's pretty wild. Okay, so picture this. You're the AI behind the wheel of this car, and you see that. A garbage bag right in the middle of the freeway. It's not a person, it's not another car, it's something else, an unknown. What's the playbook for that? Is there even a playbook? So, really, what do you do? Swerve? Hit the brakes? Or maybe you just plow right over it. For a human driver, that's a gut call, right? An instinct. But for an AI, that single split-second decision, that's one of the toughest nuts to crack in all of autonomous driving. So, to really get why this is such a headache for computers, we've got to look at how these self-driving brains have been built in the past. It's kind of a tale of two very different approaches. All right, on the left, you've got the old school way of doing things. It's called a modular system, but a better way to think about it is like a committee in your car's head. You've got one AI specialist for vision, another one that's a pro at predicting traffic, and a third that's the master planner. Now, they're all super smart at their one job, but they're basically passing notes to each other. It can be clunky, it can be slow, and if the vision guy sees something totally new, like our garbage bag, the other guys might just get confused. Now, on the right, that's the new hotness, the end-to-end approach. It's one single brain, one unified model that sees the world and decides what to do all in one go. It's way faster, totally integrated, and, well, the hope is that it's a whole lot smarter. And that brings us to the main event. We're looking at a new AI from Waymo that's all in on this unified brain idea. Meet Emma. So, Emma stands for End-to-End Multimodal Model. Yeah, I know, it's a mouthful. But the really important part is that it's built on top of a large language model, an LLM. We're talking about the same kind of technology that powers things like Gemini. But here's the twist. Instead of just chatting with you, Emma is designed to look at the road through a camera and go directly to a driving action. No middleman. And check out how elegant this is. On the left, you've got your inputs. Camera feeds, text commands, whatever. Then in the middle, you just have Emma. One model, doing all the thinking. And then bam, on the right, out comes the output. A clear, concrete driving plan. It really is one mind handling everything from start to finish. Okay, but how on earth does one brain do the job of a whole committee? Well, this is where it gets really interesting. Emma doesn't think in lines of complex, confusing code. It thinks in words, in plain English. This is the core idea, right here. The whole act of driving is basically turned into a question and answer session. The AI can ask itself, hey, what's coming up on the right? Or what's the safest path forward? And Emma generates an answer, in text. That text then gets translated into a driving move. The car is literally having a conversation with itself about how to drive second by second. Let's break that down real quick. Step 1. Emma sees the world through its cameras and gets any text commands. Step 2. It turns whatever problem it's facing into a prompt, a question. Step 3, the language model brain spits out an answer in plain text. And finally, step 4, that text gets decoded into a real-world action, turning the wheel, hitting the gas, or braking. So because of this whole language-based thing, Emma has some abilities that the old-school systems just can't touch. We're going to call them its 3 superpowers. Okay, superpower number 1, it can think out loud. This is a big one. Because it thinks in language, we can literally ask it, hey, why did you do that? And it can explain its reasoning step by step. The technical term is chain of thought, and it's an absolute game changer for actually being able to trust these things. Just listen to this. This isn't some note an engineer wrote after the fact. No, this is the AI's actual internal thought process. It sees the cyclist, it figures out what they might do, and then it explains its own logic for making a move before it even does it. That kind of transparency, that is a huge, huge deal for safety and for our peace of mind. All right, superpower number 2. Emma is a multi-talented generalist. Remember that clunky committee we talked about with all the different specialist brains? Yeah, Emma doesn't need any of that. It does everything, seeing, predicting, planning, the whole shebang with just one brain. Now, you'd probably think a jack of all trades would be a master of none, right? That a generalist would get smoked by a specialist. But just look at this chart. The bars on the left, those are your specialist models, each trained to do just one thing really well.
And on the right, that's our generalist, Emma. And wow, it's performing just as well, and in some cases even better. It seems like seeing the whole picture at once actually makes you better at all the little pieces of the puzzle.
And that brings us to the third and final superpower, scalability. This is a classic trait of these big AI models. Just like the LLMs and chatbots, Emma is basically a data monster. It's always hungry for more, and the more you feed it, the smarter it gets. This graph right here shows you exactly why that's so exciting. So as you go from left to right on the chart, that's us feeding Emma more and more data. And this line going down, that's the number of mistakes it makes. It's getting better and better. But here's the kicker, look at the very end of the line. It's still dropping. It hasn't plateaued. That tells us that Emma still has a ton of room to grow. It's not even close to being as good as it can get. All right, so the theory and the charts are all great. But the real question is, how does this thing actually perform out on the chaotic, messy roads of the real world? Let's take a look. Seeing is believing, right? Okay, check this out. A squirrel. Now, the engineers didn't sit down and create a squirrel detection module. They didn't have to, because Emma's language brain has this general, common-sense knowledge about the world. It understands the concept of a small, fast-moving animal, and the rule, you probably shouldn't hit it. So it just generalizes. It figures out what to do, even though it's never seen this exact situation before. That's not just programming, that's something that looks a lot like real intelligence. Or how about this mess? A classic construction zone. The lane is totally blocked. An older system might just freeze up. But Emma sees the cones, sees the truck, and understands that this is a temporary situation where the normal rules of the road get a little flexible. So it confidently plans a safe, decisive move into the other lane to get around. That's some pretty sophisticated reasoning, the kind that's been a real struggle for self-driving cars until now. Now, let's be real, this is still very much in the research phase. There are some major hurdles to clear. For one, it's only using cameras right now, so it doesn't have that superhuman 3D vision you get from sensors like LiDAR or radar. It also takes a boatload of computer power to run. And maybe the biggest challenge of all is testing it safely. I mean, figuring out how to let this thing make its own decisions in the real world, what the pros call closed-loop evaluation, without any risk, well, that's a seriously tough problem. But hey, even with those challenges, you can't deny this is a pretty huge leap forward. What we're seeing here is an AI that doesn't just react based on programming, but one that actually reasons about the world, and does so in a way that feels surprisingly human. So it really makes you wonder, right? Is this what the future looks like? Could this kind of single thinking, talking AI brain be the thing that's powering every single car on the road one day?